Hey guys, welcome to 2.3 Lipids. So let's review. Lipid structure. Now, when we're talking about lipids, we're talking about fats and waxes. So you have fats, which are triglycerides, right? Oils and waxes. And these provide energy storage for cells, structure like the cell membrane, insulation, right? But primarily, we're going to focus on the fact that lipids and proteins compose the cell membrane in a couple of important ways. Another lipid you should know is cholesterol. Cholesterol is a steroid that helps give membranes flexibility. Now, if you look, you'll also notice these funky little rings there, right? Meaning that cholesterol is actually a lipid plus a carbohydrate. But what we're going to focus on, lipids. Okay, so let's talk about lipid structure. Lipids have two major parts. You've got your glycerol head, which is hydrophilic, and you've got two fatty acid tails that are hydrophobic. Now, technically, that means we have two monomers. One monomer is a glycerol, and one monomer is a fatty acid. And you need those two types of monomers together to have your polymer, which is a lipid. If you were to look at it in a three-dimensional model, it would look more like that. You've got your hydrophilic glycerol head at the top. Remember, hydrophilic means it likes water. Hydrophobic means it doesn't like water. And that will become clear as we continue. Like we said, the monomers of lipids are fatty acids and glycerol. The polymers are lipids like triglycerides and phospholipids. Our ratio is going to be 1 carbon to 2 hydrogen with just a few oxygen. So it's no longer that 1-to-1 ratio like we saw in carbohydrates, right? We only have a few oxygen. So let's jump back into our understandings. Now remember, these understandings, they come from the applications, understandings, and skills, that guide list of what you need to know. So fatty acids are the monomers of lipids, right? And we have saturated, monounsaturated, and polyunsaturated fats. Saturated fatty acids are animal fats, and these guys tend to be solid at room temperature. Like butter or Crisco or lard, bacon grease, right? Solid at room temperature. These are saturated fatty acids. Now, here is this long fatty acid chain, and you can see every single one of these carbons is single bonded. There we go. Except for this one, it's got a double bond. But in the chain, right, these are all single bonds. There is a hydrogen at every available place. That is why we call this a saturated fatty acid. It is saturated with hydrogen. So you know that if your carbons are all single bonded and there's a hydrogen at every single available space in this chain, that's a saturated fatty acid. Next is an unsaturated fatty acid. And these are vegetable oils. These guys tend to be liquid at room temperature. Think about olive oil or peanut oil. I think olive oil is my favorite. Now, that change in phase is related to the fact that you'll notice there are some double bonds between carbons in this chain, meaning there are spaces where there are no hydrogens. So no longer is this saturated, it is unsaturated. There are not hydrogens at every available place. These double bonds between carbons prevent bonding with a hydrogen in certain areas. This is unsaturated. Sometimes you'll see saturated or unsaturated fatty acids drawn like this. And this is just kind of a simple and lazy way to draw it if you don't feel like writing a million carbons and hydrogens. So, saturated fatty acids are saturated with single covalent carbon hydrogen bonds. Unsaturated fatty acids have double covalent bonds, which affects their shape. A mono-unsaturated fat has only one double bond, mono meaning one. So mono-unsaturated means one double bond between two carbon atoms. Polyunsaturated fats means there's multiple double bonds between carbons. So this is a mono-unsaturated fat because there's only one double bond. These guys are polyunsaturated fats because they have multiple double bonds. So here we go. Saturated versus unsaturated. I want you to tell me which has more hydrogen, the saturated or unsaturated. Let's find out. Well, this one has 18, and there's no double bonds. So we say that this is what? This is a saturated fatty acid. Here's our unsaturated fatty acid. It's only got 16. This double bond causes two hydrogen to be missing. The double bond reduces the need for more hydrogen atoms to stabilize the molecule. All these carbons want to be stable. Understanding number 3. Unsaturated fatty acids can be cis or trans. And yes, that's why we use those words cis and trans. Like the words were actually prefixes that are used, they're Latin prefixes that are used in science to describe whether something is on the same side or opposite sides. So, cis fatty acids are missing hydrogens on the same side of the double bond, causing the tail to bend. So here we have a cis fatty acid. You can see we've got all these single bonds. Here we have the double bonds, but we have hydrogens on one side and no hydrogens on the other. That causes this to bend. And that's because there's no hydrogens here to keep it straight. Now, on trans fatty acids, they're missing hydrogens on opposite sides of the double bond, and that helps them maintain that shape. You can think of these hydrogens as like braces for the structure. If you're missing two on one side, that's going to cause a weak point and the molecule is going to bend. However, if you're missing two but they're on opposite sides, that these two still give you enough rigidity to hold the rest of the molecule in line.